given. One half times x is less than 3, or 3x minus 1 over 2 is greater than 4. Let's see, we are going to find graph of this compound inequality. Solution. Step 1. Simplify each inequality. Now to simplify, that means to get x alone on the left side. So the first inequality is 1 over 2 times x is less than 3. And the first thing I want to do is get rid of the fractions. I'm multiplying both sides by the LCD, which is equal to 2. So multiply both sides of the inequality by positive 2. You get 2 times 1/2 times x is less than 2 times 3. I did not flip the inequality because I multiplied both sides by a positive number. Cancel the 2's, and we get 1 times x, which is x, is less than 6. So here we have the simplified form of the first inequality. Then the word or we could use the union symbol. The next inequality is 3x minus 1 over 2 is greater than 4. The LCD for this guy is also 2. So we're going to multiply both sides of this inequality by 2. Over 2. I put the parentheses around the numerator because there's 2 terms up there, and in a few minutes I know I'm going to have to be really careful. And, well, no, I won't have to, because I don't have to distribute the multiplication by the upper 2. It actually cancels with the bottom, the factor of 2 on the bottom. It just leaves 3x minus 1 is greater than 2 times 4 is 8. Okay, so, I'm not finished. It's too early to put the cloud around there. I'm not finished yet. We have to get x by itself, of course. So now we'll add 1 to both sides. We get 3x is greater than 9. And then divide both sides by 3. We get x is greater than 9 divided by 3, which is 3. Now we put the cloud. Thus, we have the simplified version of these inequalities. X is less than 6. Union together, because that's the same as the word or. X is greater than 3. Now, you could stack the number lines and union these two together, but these are pretty easy. They're not overlapping each other, so it's not going to be hard to oh, wait a minute, they do overlap each other. My bad. Okay, so let's do the stacked number lines. X less than 6. We're going to graph that on this number line. And right below, x is greater than 3. We'll graph that inequality on this number line right below. And then the union of the two, we'll graph, I'll put the union cup, we'll graph that on this last of the stacked number lines. Now, the only numbers we're interested in are 3 and 6. Well, 3 comes before 6, so put 3 here and 6 somewhere over here. And line them up directly below on each number line, exactly lined up. Okay, first one says x is less than 6. So we're going to shade everything that's less than 6 with an arrow at the end. And since it says less than, but not less than or equal to, we cannot include the 6, so we put a round bracket. So we shaded everything up from negative infinity up to, but not including 6. X is greater than 3 on the next one. Shade everything greater than 3. And then put a round bracket on the 3 because we're not including it. There's no equal portion in the inequality. And then for the union, we're going to shade everything from the first set together with everything in the second set. And the best way to do this is first look at values of x on this last number line that are less than 3. Look above at the two inequalities. Do we have any shading through values of x less than 3 in the first set? Yes. Well, if it's shaded and included in one of the sets, that's enough. So we're going to shade that here with the arrow. How about the middle region? Well, we have shading for the middle region on both inequalities. We have more than enough to shade the middle one because union has everyone invited, everything in the previous sets brought into the union. And then for values of x greater than 6, yes, on the second set we have values of x greater than 6 with an arrow. And then just be super careful about the endpoints. Is 3 actually included? It's not included in the second set because it has a round bracket, but it is included in the first, so that's enough to shade right through it in the union. And then this number 6 is not included in the first because of the round bracket, but it is included in the second as it shades through it, so include that shade right through it. And there's the graph. That is the graph picture of our solution. Now we could also do that graph, we could write it in interval notation, which would be everything from open negative infinity to positive infinity. Close that. And we could also do set notation. Just put the funky looking R for that. Okay? So we've got our 3 different types of notations: graph notation, interval notation, and set notation.